Remote sensing is a concept that we use these days widely. You may think this is something deal with satellites and all other things. Many things will pop into your mind when we use the term remote sensing. When I say about remote sensing, but it's not such a complicated thing. It's really simple thing as you see. Yes, you're correct. It deals with satellites and receivers and some things called sensors and some other radar, sonar, lidar, such whole another set of words you may need to deal with when you're studying remote sensing. But it's not such complicated. Yeah, you are correct. Google mapping may pops into your mind. You are correct in that. Remote sensing and mapping systems have a really special bond. So, what is remote sensing? You may wonder. Simply, remote sensing can be defined as a technique or a science of obtaining information about objects through the analysis of data collected by special instruments that are not in physical contact with the objects of investigation. Simply, remote sensing is acquiring data from an object or surface which we can't physically contact. Physical contact without no physical contact means without no touching. Simply I can use that word without no touching. Simply you can say some an object which is far away from you, so you can't really be physically contact with it. So you need to acquire data or information from that object. You use this technical term remote sensing. So when the information needs a physical carrier to travel from the object, we use the instrument called sensors to complete this task. And also another thing is electromagnetic radiation is normally used to carry this information, as it acts as a carrier in remote sensing. And also another important thing is output of remote sensing is usually an image. A photograph, we use the word image, but photogrammetry you use it's okay to use photograph representing the scene which is being observed. When it comes to history of remote sensing, it goes far beyond, as you think, over 150 years to 2 centuries back. Because today remote sensing is a science which thing which deals with satellites and all the other new technical devices, complicated stuff. But those days, this acquiring information from an unreachable object was done simply with pigeons. Yeah, you may feel so silly about this, but in 18th century, you may believe it or not, I don't know, check the internet. In 18th century, people have used pigeons with attached cameras to have photographs of the areas they want to discover. So that's simply remote sensing as well. And also the idea and practice looking down at Earth's surface emerged in 80s with the invention of camera. Actually, just the invention of camera, then comes invention of balloons, then comes all the things, new inventions comes, then the remote sensing concept developed through that as well. And satellite remote sensing can be traced to the early days of space age and Cold War, which happened between Russia and America. And it did a dual approach to image surfaces using several types of sensors from spacecraft. Then the term remote sensing wasn't used whether these things related. It's true, these things are remote sensing, but the term remote sensing was officially used after 1950s. It was introduced by Miss Evelyn Pruitt from United States. That's a bit history from remote sensing. And today, or any other reason from the history, elements of remote sensing can be divided into 7 parts. Here you can see a simple diagram here. Simple diagram. Here you can see A. What A, B, C, D, E, F, G. So these are the basic elements of remote sensing. Involved in remote sensing. Here you can see A, you may see a sun, but sun represents a sun or any other source of energy is represented by A. Then you can see the energy travels through some kind of medium is between the energy source and the surface, or we use the term target. That between these two things there's a atmosphere. Simply you can say atmosphere, or there's radiation or atmosphere between these two Here A stands for energy source. You see sun is an energy source, so A stands for sun or energy source, or energy illuminator, so it illuminates energy. So the energy which is illuminated by this energy source is traveling to the target, which is here C, target or the surface. The thing we need to simply observe is coming through a medium. This medium can be radiation or simply atmosphere. As the energy travels from its source to the target, it will come in contact with or interact with the atmosphere or radiation when it passes through. This interaction may take place second time as the energy travels from the target to the center. Then here C stands for target, or you can say interaction with the target. This energy travels from through atmosphere. Here interacts, it impacts with the surface or a target. So that interaction is defined by C here, and it's also after that interaction. Here we see D. D stands for not for satellite, of course. It's for sensor, simply a sensor. I used previously this word sensor. Sensor is a whole another concept. We discussed it further later. Then after energy is being scattered by or emitted from the target, this energy needs to have a sensor to collect and record the information we need. The information we need is radiometric radiation. We'll talk about that later as well. Here we just simply discuss about the process of remote sensing. The process involves in these elements. From here we discussed 3 of them. If you want me to repeat, energy source and atmosphere and radiation, and also interaction with target, and the 4th stands for the sensor, data collection from the sensor, recording done by the sensor, and also after that recording collecting the electromagnetic radiation was done, then energy has to be transmitted. Simply transmitted. Yeah, energy has to be transmitted or recepted and also to be processed. The energy recorded by the sensor has to be transmitted when it is in electronic form. It needs to be done because it needs to be received or processed where to have this processed data on an image, or you can say hard copy or digital copy. To have this image, there's another these transmitted data needs to be interpreted or analyzed. To analyze or interpret it, there are certain devices for use for that, but we need to interpret or analyze this data to have a visual or digital output of this of our of information we've taken so far from the energy source. The processed image that so far is visually or digitally can be interpreted or otherwise electronically to extract data or information about the target which was eliminated. Here you say energy was eliminated, then it comes to atmosphere and made an impact or interaction, and sensor did his job by recording that energy, and also it was delivered to the transmitter. Here you can see an antenna. We'll discuss it further later. All of these things will be discussed later for further information. And after transmitting was done, then it was interpreted here and analyzed. Then final element of remote sensing process is the application. It means to extract from the image about the target and in order to better to understand it and to reveal information or all of things are done to simply to solve a problem. So reveal some new information regarding that problem. It will be done by the application. So here these are the elements regarding the process of remote sensing. I may wait. You can pause and take a screenshot if you need. So let's move further. Then here we use, I told you we'll discuss further later about sensors, and remote sensing sensors are divided into two categories, and those are active and passive. And active sensors are simply this remote sensing sensors which uses an artificial source for energy. Artificial source for an energy, that's the key word. Artificial source for energy, you can say simply satellite itself can send a pulse of energy. It can interact with the target. That's what we call an artificial source for energy. You can say it in another way. When we talk about further about active sensors, these detect responses from objects or the things we need to observe, which are irritated from artificially generated energy sources, of course. For if you want to know more about artificial source for energy, you can simply search Google about radar. We'll discuss about radar, of course, later. They have, own source of energy. These sensors, own source of energy, and of course, if you wanna, I could talk about radar first, and also laser altimeter is another thing. And also another advantage of active remote sensors is the possibility of working in day and night. There's an advantage of this type of sensors, active sensors, of course. And of course, then we come to passive remote sensing. These simply depend on a natural source of, or not an artificial. Yeah, active sensors depend on artificial, and here we see passive remote sensing about natural, depend on natural source. For example, sun, most powerful and commonly used source of this remote sensing. And for all the sun's concept, sun is, we are glad to have sun, of course. Passive sensors, of course, detect reflected or emitted electromagnetic radiation from natural sources. Simply, you can say that. And also, this depend on external source of energy, which is natural. It has to be natural, otherwise it won't be. We can't call it passive. And also another thing is that this sensor, in case, records primary and radiation that's reflected from the target. You can see passive sensors, natural energy source, sun, active, snow. There has to be an artificial energy source. Then we come to platform. Platform is one of the key elements of remote sensing. There are 4 key elements in remote sensing: object, and also sensor. And we discussed before that sensors. I didn't tell you those are they are one of the 4 basic elements of remote sensing, but there are 4. I forgot to mention there are 4 basic elements in remote sensing. Previously I talked about fundamental elements of remote sensing process. Don't mix up, don't mess things here, don't mess up things in your head. Those things were related to remote sensing processing. Remote sensing process, there's a process of the things needs to be done in remote sensing. In that process there are some key elements. Those were discussed earlier. Then when we're considering about the 4 key elements, basic elements in remote sensing, one is object. There's nothing to discuss about object. Actually, object is the thing we need to observe. Or if you need a definition for that, I would say object is the thing that, which is on sensor's field of view, which is the thing that sensor is directed. There's a sensor, there's object. So of course, when it comes to sensors, it has to be directed towards something. The thing which is sensor being directed is the object. Of course, and satellite based remote sensing, the observed object is always sun, always the earth. Always the earth. And we discuss what is a sensor. There are two types of sensors, active and passive, two categories, and sensor is basically a device used to acquire, photograph, or an image. It will basically sense or measure the amount of energy, radiated energy actually, which is reflected from an object. So those are not the things we need to discuss further, but those are basic things. Just need additional slides on my presentation, of course. So then we come to third element of this remote sensing. It is information. One is object, next one is sensor, then the information, the form of information which is obtained from the remote sensing, and also the method of storage. That's the third element. So I will repeat. The third element of remote sensing is the form of information object from the remote sensing and the method of storage. Okay, so there are three elements I've discussed now within 2 minutes, I guess. So of course there's nothing to discuss further. Then we come to platform. So platform is the base. It's the base which remote sensors are placed to acquire this type of information. To have an overview of Earth's surface, it needs to be at a reasonable distance away from it. When it comes to air balloons or aeroplanes, which are vertically above the surface. So these are examples for platforms. Here you can see ground is there, and low altitude data, high altitude data, and satellite data. Low altitude data can be taken from drone, maybe, then aerial photographs, then satellites. Remote sensing is not only about satellites, I would say. Much more about satellites, but not only about satellites. So these platforms can be divided into three parts: ground-based, airborne, and spaceborne. Three categories, of course. Then ground-based platforms, simply, we can say those are the platforms on the ground. Of course, vehicles, can be vehicles or stations, which can be, you may see in movies, wherever the remote sensing happens, there's to be a tower, something called a station. It may be a tower or something, up to, from the MSL up to 50 meters, there can be ground-based platforms anywhere, not anywhere, but they can be. If you want to have a ground-based platform, you have to do it within this limit. Then airborne platforms, it can be helicopter, aircraft, balloons, anything. Then spaceborne. When it comes to space, which is far away from Earth's surface, from 100 kilometers to 36,000 kilometers. Space shuttles, space stations, low-level satellites, high-level satellites. Here you can see with them, with the minimum height, they can be, they can be stationed. Spaceborne platforms can be there. Yeah, before going further, I would say I talked about 4 elements about remote sensing, and things bit complicated from bit complicated because from this minute we talks about airborne, airborne things, area photograph. Then next we come to or another level in the space. So remote sensing is a very widely spread subject. When we study, there's no proper limitation for that, so you have to keep that in my mind. From the area photograph to satellite image, that's all in remote sensing. So I decided to talk about why we need to study remote sensing. Actually, you may wonder actually here are some key advantages of remote sensing. If you want to remote sensing usually uses in many areas, like land use mapping. Of course, in mapping, remote sensing, unbreakable bond there between those two subjects. And also forest and application map, agriculture applications, of course. And also then comes to meteorology, urban planning. I can go on, environmental application, all the stuff use remote sensing. And always the reason for remote sensing used these areas is remote sensing always provide a regional value. Remote sensing can be applied to large areas simply. And also when you will discuss later about how the repetitive looks can be happen when using remote sensing. And also remote sensors used to see over the border and the things we cannot see from the human eye, beyond from the spectrum of the human eye. And also provides your reference data. Of course, remote sensing provides georeference data, so there's another advantage of using remote sensing. And one of the reasons that remote sensing is being used in the areas that I explained before. And also remote sensors can be used night and day, good or bad weather conditions. So not all, most. And here are some disadvantages of remote sensing. I don't like to talk about this, but remote sensing is a bit complicated even for people who deal with remote sensing would say they won't 100% fit into the subject. But also remote sensing is expensive to build and operate. And also remote sensing depends on the verification of the surface or the ground, and also the tool, the device or equipment. Most of the tools are not good for small areas, of course, and being an expert is essential. You can't deal with remote sensing without at least being an expert of the concepts. So there's no need to remind these things. So here I mentioned before that meteorology, oceanography, glaciology, and geology, some areas that remote sensing is being used. In meteorology, profiling the atmospheric temperature and vaporization of water can be done through remote sensing images. And also the measuring the velocity of the wind can be done by using remote sensing. And hydrography, oceanography, measurements of sea surface temperature can be done with remote sensing. And also ocean current, mapping ocean currents. It's an interesting area which is used remote sensing. And also glaciology, mapping motion of the sea and sea ice and determining the navigability of the sea, and comes to geology, rock types and geological faults and anomalies can be studied by using remote sensing, and also agriculture, hydrology, disaster control. I forgot to mention disaster control. You know, whenever there's a disaster happen, always always media shows the one thing for sure, that is how the disaster spread throughout the area by using remote sensing images, satellite images, monitoring, pollution, air pollution, maybe ground pollution, anything can be done by using remote sensing images, and also hazards, emergencies. Remote sensing is very helpful those areas, and hydrology, just like oceanology, water resource assisting and forecasting meltwater can be is studied throughout remote sensing images. And also agriculture, when it comes to agriculture, the extent of the type of vegetation, soil types, all the things can be mapping or monitoring throughout remote sensing. So you can say this is the area I need to use remote sensing. Wherever you go, there's remote sensing. So that's all for now. So hope you learned something from this video, and this is just a basic look at remote sensing. Of course, I just touch things need to study further. We will study, just we discuss what is remote sensing, and of course remote sensing process, the elements including which are including in remote sensing process, and also basic elements of remote sensing. Then that's all for now. We will discuss about further about remote sensing throughout our next videos of this lecture series. So bye for now.